Hello and welcome to a new session of Hitchhiker's Guide to the Glamorous World. And today I'm joined here by Pavel Adamchuk. Hi, Pavel.
Hello.
Nice to meet
Right.
you.
So maybe I'll quickly introduce myself. My name is Pavel Adamchuk. I work at Relativity currently. I have several years of software development experience, mostly with enterprise kind of applications. Full stack, but mostly backend development. Yeah, and I'm interested in the idea of moldable development and just want to find out more how it could apply to the cases I've seen at work.
Great. Thank you. So one of the, we got in contact just a couple of days ago. And one of the things that that drew my attention to your remarks on our Discord was that the presentation of what, for example, what Glamorous Toolkit is not particularly clear and doesn't necessarily convey how one might extract value with it, for example. And we said, well, let's go into a conversation to see what it is, and then potentially what do we learn from this. So let's start with this one. What do you think Glamorous Toolkit is from what you've seen so far?
So what particularly caught my interest when I first saw Glamorous Toolkit, it was quite a while ago. I remember checking it out some time ago. I think I've heard about it on Hacker News on both occasions back then and several days ago. And this time I found the Discord link, decided to join, see what people talk about, to see some specifics. Because really, I think the problem statement is really valuable, because I think any developer with some experience will admit that, discovering new code bases and onboarding new people into teams working on code takes a lot of effort. It takes a lot of mental space for developers and a lot of time to keep up to date with all the changes in the projects. So I imagine Glamorous Toolkit as a way to help power this discovery in a way different than traditional documentation, because like the problem with documentation is that it goes stale quickly as the code changes, and as valuable as diagrams about the code, about the architecture are, you really you can only treat the code that's actually in production as the ultimate source of truth of how things work. So I imagine Glamorous Toolkit to be kind of, and the approach of moldable development to be an attempt to document code bases in a more dynamic way, kind of like maybe dynamically generating documentation and making it, also by the way, making it more visible to less technically inclined people, maybe like product side of things. So that's my initial impression, without getting into technical details yet. But what I started wondering when I was checking out the website was how this approach can apply to specific technologies, to the ecosystems I have encountered personally in the workplace. I work in terms of technology. I have worked mostly with .NET Framework, .NET Core, on front end with various JavaScript frameworks as well. But yeah, but it's mostly C# code, and I I have seen things that maybe try to approach the idea of moldable development in a way, but people don't use them a lot. For instance, I recently noticed in our in the knowledge base we use at the company currently, we use Confluence, and we do have a lot of dynamic pages that are generated basing on some code bases on infrastructure as a service, stuff like that. And I really, I tend to really welcome any automation I can see, because when it comes to generating of documentation, you can rely on it. Unlike, like I mentioned, the documentation. It doesn't go stale when it's regenerated automatically.
So that's interesting. Quite interesting summary. So let's see. Where do we start? We start from. So we start from. Let's take it from the motivation. The goal here is to indeed empower one to reason about the system. You mentioned quite interestingly that on the one hand, having documentation is like interesting, but it can go stale. Now, why does it go stale? I mean, it doesn't, documentation doesn't rot. It just goes, it just remains behind, right?
Yeah, it goes out of date as the code
But
changes.
if you think about, but there's an assumption here. The assumption is that when it was first written, it was accurate. And that's actually the
Yes.
problem. That's the problem that we actually start from, because that's a belief, right? Whenever, anytime
Yes.
somebody manually depicts the system, that depiction represents the belief of the author. It doesn't represent the system. It's an important piece of documentation. It's an important input because, for example, this is where you get the why. This is where you get an idea of intent. But it should not be confused with a documentation of the system. Because the system, as you said, is always the running thing. The running thing does not give you the full picture, indeed, but it's the basis from which you need to start. So the running system should never be an unknown. We have it's difficult enough to build systems. Not knowing what the current system is should not be one of the variables in that problem. And that's where we start from. That's the basis. You wanted to say something?
Yeah, because like I definitely understand what you're saying. Like you introduce kind of a human element in the process, and that's really a source of potential errors. Like as you said, it's a belief. Every time you make a diagram of the system, every time you make a discovery of an old code base or something like that, and try to put it into documentation, yeah, that's right. There is potential for errors there.
But the thing is, and let's just think. So, how large is your system, for example? A typical system that you interact with?
Well, depends in terms of lines of code.
For example,
I'm not sure, honestly.
Would you put it in within 1 million lines of code, less, more or less?
Probably usually more.
More. Let's take 1 million.
1 million or more, yeah.
Fine. Let's suppose it's 1 million.
Yeah.
So 1 million lines of code. Let's say you read really fast. Let's say you read one line in 2 seconds.
Yeah.
If you do the math, and let's say you can keep it up for 8 hours per day. If you keep it up, like it will take you about 4 months of effort to go through the whole code base. So anyone that drew anything about the system and did not read the whole thing,
yeah,
it does represent a belief. Yes. And that's the thing. We are so convinced that the thing that we have thought of is actually what gets into the real thing, that we do not realize the bias that is based, that is built into that
Mhm.
assumption.
And I
And
think an interesting thought experiment to illustrate your point here is like you have to make so many assumptions when you're reading, let's say, enterprise code written in C# or Java, because that's what I'm most familiar with. You make so many assumptions based on naming of modules, naming of functions, services. Like if you imagine all this code, the exact same functionality, but let's say written in assembly code, reading this really would take orders of magnitude more time than reading the code written in, let's say, Java. And if you were really as thorough as a machine could be, there wouldn't be a difference to you, right? Because the
exactly,
functionality is exactly the same, but you are a human and you need to make a ton of assumptions when reading that code. So that's where the belief factor comes in.
right. And the problem is that reading doesn't scale. Nobody reads the whole thing.
Yeah.
So people make up a lot of the things, very much like how we are, making up the shape of the animal without waiting for the whole animal to appear in
Yeah.
front of us. So, but this is detrimental when we want to do engineering. And so, the first thing that we want to solve is obtaining information from the system, considering system as data. That should be almost instantaneous. It should be pervasive, and we should be able to get it, anytime. Like everybody should be able to get answers about the system. And the reason this is important is because this is the single largest expense today. So developer spending time reading is just the most manual possible way in which we can extract information out of systems. And given that we spend so much time on it, then the question is, well, what else can we do with that budget, right? Because the budget is already allocated. That's the interesting thing. So we don't have to ask for permission for management or for whatever business, or because we're already spending it. The interesting thing is we're spending it in the most manual possible way. And the skills we need to transform this one is, guess what? Well, those are the skills for which software people are actually paid. Right, so we automate everybody else's decision-making process. Shouldn't we be able to automate our own?
Yeah.
And of course, now, so that's the basic frame. Now, of course, then we have to look into the details, right? Because now, it should follow that, you were mentioning visualizations, right? So you're generating visualizations, and that's great, right? They can, you get a picture. It can be, basically it can cost zero once the automation is in place. The question is, which picture? Because about a system, you can draw maybe millions of pictures, each potentially interesting. And maybe if every one of them is interesting for a certain perspective, but they will not be interesting from most perspectives. That's the thing.
They are all models, because you try to compress information, and it's lossy compression, and like all models are wrong. Some are useful, right?
But it's important to say for what purpose, right? Because a model is guaranteed to be interesting for a certain for a certain set of questions. So the interesting thing, or the interesting characteristic about software, is that software is highly contextual. And so if you move from one system to another, the classes of questions that you will ask might be similar, but the specific questions you will ask will be really, really different. In fact, within the same system, if you move from one place to another, it's going to be different questions. Within the same system, within the same place, in two different moments in time, you will be asking different questions, right? And so I mean, just, simple things. I don't know, if you're on the UI or you're on the server side, you're just going to ask different questions simply because of the nature of the area, right? If you're in a business part which does something with, I don't know, accounting versus something that does something with the management of, I don't know, users, you're just going to have different kinds of, characteristics, and that you're going to that will appear in the questions.
Mm-hmm.
But sometimes even within the same thing, let's say if I'm looking now and I want to build this domain versus I want to make it performant versus I want to make it secure, those are going to be different questions that will pop up because of those.
Yeah.
And even if they appear about the same thing, and there are many other ways in which you can slice and dice a system and look at it from find the perspective to look at the system from. And this is why it is not enough to have automated summary generated or some summarization pictures or reports of sorts. Those have to be specific for your question in order to be useful. It's not enough to generate something. It's very easy to generate lots of pictures. Generating useful ones, that requires a different kind of picture, because that means, given that you cannot predict the specific questions you'll have, it follows that you have to build the picture. You have to define what picture is interesting only after you know the question. You can't do it before you have the question, simply because you don't know. And in a way, it's kind of similar to how you're, if you consider testing. Nobody downloads a unit test from the web. You never download a unit test from the web and apply it to your system.
Yeah.
Right? You're always going to write a unit test specific to your system.
Mm-hmm.
And what's interesting about this is that, many people are just taking, for example, static analyses from the web and just applying them to their system. So both of those are actually the same thing. They're just analysis, which means that they take lots of data and then they summarize them to you in some form. But they are treated differently, right? And then you notice behavior like in the same team, there are 0 failing tests, and then you have 10,000 warnings for static analysis from static analysis tools. Why? Is it because people don't care? No. It's because people spend the time to put the assertion into the test. And so when the test fails, they know that it has value within the context of the system, because that's what the assertion says. The assertion says there was a valuable thing here and now it's no longer true. Well, with the other one, the thing that I've downloaded from the web, right? Who created the analysis? Somebody else, which means now that thing, which might be interesting from a technical perspective, but from the perspective of what it solves somebody else's problem. And those problems, they are not transferable in details between one system and another, just like we have seen before. Yeah. And that's the reason why it is essential to learn, that we can learn from what we've done with testing. And the flow is always like this. I have a problem, I create a tool, and then I'm going to use the tool. I never switch those. I never start from the tool and then I pick the problem. It's always the other way around.
Yeah. And I can see it in practice, like whenever I seen automated static analysis of some sort, tools like SonarQube, for instance, for analyzing code bases, you can see that the scope is so broad, but only part of it applies to specific environment, to the piece of software you're working on. Like some code smells, for instance, will be unacceptable at one company, at one project, but they will be totally fine and they will be justified at another place. Yeah, so that it does make sense. And usually, like, the more information you have, you're kind of sometimes overwhelmed by the information from the static analysis tools, because like you run it on your project and you get like 500 errors or warnings, let's say, and like nobody's gonna take time to go through all of them. Like it's hard to even decide which ones require attention or not.
Exactly. Okay, so let's take a moment. So just take this one as an example. Do you also have failing tests as much, or are your tests green most of the time?
Yeah, the tests are green most of the time. They're limited in scope because you start, right, like you said, you start with the question.
But sometimes it's possible that somebody messes up something, and all of a sudden you have 1,000 test error, error test errors.
Yeah, but
So
then there is an assumption that those are things you really need to fix. It's
that's
like,
the difference.
yeah.
It is not the amount that makes the
Hmm.
difference. It
Yeah.
is the fact that there is value in one because you know that
Hmm.
you put it there, and you have
Yes.
the instinct to say, yeah, I mean, we can just say all sorts of things about also. I mean, you have a million lines of code. You can talk about this one for a long, long time, but it doesn't
Hmm.
necessarily makes it interesting. And it's the value that drives behavior. But we
Hmm.
can turn this around. What if all your tools, static analysis, logs, and whatever, anything that you're looking at, what if you're always going to build those after you know the question? Some of them you might reuse, some of them you might put in the CI, some of them I might just going to use for, 5 minutes and then I will throw it away. Why not? Just think of a database, for example. If you have a problem in the database, like the data in the database, something's not quite right there.
Hmm.
What is the first thing you're gonna do? What would you approach it? Like there's something that doesn't match in the data. You kind of have an idea of what the data is, the schema, but now something's not quite right. What would you do?
Oh, if the data in the database is inconsistent, then first I'm going to look for, the root cause of why the data is inconsistent.
But first, you
The
need to
root
know how it
cause.
is inconsistent.
Yeah, yeah, yeah. You need to
How do
define
you how
how
do you
it's
look for it?
inconsistent.
How do you look for it that it is inconsistent?
Well, a lot of the time you can start with thinking about, from the perspective of the business domain you're in and what makes sense and what doesn't, like what relations make sense, what values make sense, and like here also I think lies great power of database management systems, because like you can code those constraints yourself, and you
Sure.
can
How do you do that?
you can make sure the data is consistent. Well, you have all kinds of limitations you can put on your data. You can put foreign keys, for instance, to explicitly codify relations between entities. Something you don't have by default when you're starting a C# project and start creating objects. Like the
Mhm.
relations are not explicit. When looking at the database, um, you get a better picture of the business domain basing on those relations. And to go kind of more abstract on this concept, I think of it in terms of the limitations you put on your tooling, on the systems that you use. For instance, when you compare really dynamically typed, let's say, languages like JavaScript, for instance, with more strongly typed languages like C#, people say JavaScript is so powerful because it lets you use so many programming paradigms. It's so flexible, but with this flexibility comes the lack of limitations that really help you reason about the system in place. Like I find it's much easier for me to read a database structure than a JavaScript code base, because there's more explicitly there's more assumptions and limitations explicitly put into your code base, into your tools. I don't know whether that makes sense, but
It does make sense.
well,
When you're looking at things statically, but when you're looking at data, let's say that some values
mhm,
don't match up. If data is already in the database, which means
yeah,
it has passed the constraints of the schema. Um, the first thing you're going to do is you're going to say, oh, let's open an SQL and see how much of those are like this, which are little like this. And you're going to do a select, for example, or,
yeah,
uh, and so, it's interesting how this kind of behavior, right? Whenever starting any data investigation, mostly by writing a query first, how that behavior matches so well the shape of a typical database tool, which is query box at the top
Yeah.
and then some data at the top, at the bottom, right? So what you're going to do first, you're going to write the query, you're going to
Yes.
look at the data, write the query, look at the data, and then until
Mhm.
you kind of figure things out.
I think
So
I kind
first
of
of all,
know. I think I kind of know where you're going with this, because like
so,
I remember I often save queries I've used
mhm,
when investigating certain issues to
sometimes,
be
right?
used later. But yeah.
But you never start with the assumption that you're going to save it. You're always going to say, oh, I'm just
Yeah.
going to, it's just going to be much
Yes.
faster. Like there is no economic, it's so obvious that it's much more economically viable to start with the query than to look at things manually, that
Yes.
you're not even going to think about this. But now think of where is the query box when it comes to the rest of the system. There is none, right? So the only thing you're left is the scroll bar.
Yeah.
And so what do people do? Well, they're going to scroll because that's what the tool affords you to do. And there's this very interesting correlation between what the tool allows you to do and the kind of behavior and how you're going to map your needs and the activities, how you're going to decompose your activity based on or across the affordability of tools. The other thing that you might notice is how the the I in IDE, right, is actually stands for or should stand for integrated. But then how many times do you go away from it per day,
Yeah.
right? Because every time you go away from it, the I has failed because it's not integrated. And so, right, we're left with an editor. That's pretty much what that thing is, right? Which is a far cry. It's very distant from the goal of the integrated development environment. Um, so editing is important. It's just it's just a small part of what is interesting. So the reading part is as interesting, and in fact, we shouldn't be reading most of the time.
The I have one thought here, because I heard, you compare the you you'd like to treat the code base of your product as a data set, essentially, and that's how you're describing it.
Sure.
But I think there are some notable differences between the data sets you encounter in your database and the actual code, and that the code is it's much less constrained and it's much more dynamic. Like you can make a query and list the entries in the database and filter them in a pretty consistent way with all the limitations of the relational database. But when you're trying to do the same with code, you're sometimes going to run into some edge cases, like for instance reflection in C# and Java.
Sure.
There are some cases that can be queried automatically by often IDE tools or plugins or static analysis tools. But there are capabilities in those frameworks and languages that we use that escape this analysis. And that allows us for the flexibility of code. And that's actually one of the questions I had to you. Like, how do you make sure the tools that you build remain relevant? Because
So I can tell you. So, but first of all, let's take that. It's actually it's we get this a lot, right? Like first of all, is Glamorous Toolkit. Yeah, you can use it for static analysis of various sorts, but it is not. It's not a static analysis tool. Static analysis is just one of the types of things that you could do with it. Our intent is not just to look at source code as data, but the whole system as data. And that can be logs, can be the data in the database, the versioning system, the issue tracker, whatever you have. All of those things are the the whole piece of information there might be relevant about your data, and you should be able to compose views that relate to any of those artifacts. Sometimes you want to look at the system statically, and this is interesting. Sometimes it's dynamic, sometimes it's a combination. Sometimes you combine different sources of dynamic information, sometimes different, let's say if you have your client server type of thing, and client is JavaScript and the server is .NET, might not even actually be just .NET. Maybe it's .NET plus some sort of a framework, and it's also the JavaScript is plus some sort of a framework, and all of a sudden it's kind of different there. But you want to reason about the whole thing, right? So in JavaScript is going to call something somehow your services, which are on the backend, and that call is going to happen through some sort of library. And if you don't know the library, well, then you don't know how the services are going to be called. So, and this is, you want to have a tool that is able to reason about all of those. Now, it's interesting that you mentioned this flexibility that exists, like you can do reflection and so on. But it's true in general, right? Yeah, you can't predict those, and it's hard sometimes to do analysis on JavaScript. If you're just not assuming anything, and if you're assuming that you know nothing about the system. However, that's almost never the case. And I can give you an example in the database where you're going to have very similar problem. For example, when people take a relational database, and in one of the fields they will put an XML or a JSON inside there.
Yeah.
With all sorts of or I just going to have a blob. I'm just going to put something in there.
Yeah.
Like, isn't this happening a lot? Yes, it actually is happening a lot, right? Or when you have a column which actually is a string and encodes some notation of sorts, right?
Yeah.
And isn't that the same kind of thing? Of course, it's the same kind of thing, right? Is this, unsurmountable? No, it's not something you cannot, build around. So problems are actually not that different. The other thing to know, however, you are saying is that, systems are, so source code, for example, is less structured. In fact, it's the opposite is true. It is much more structured. Typically, we have a very strong understanding of what's in the code in terms of the structure of it. Like, I know exactly where a method ends and begins. I know exactly when there is a condition. I know exactly when I'm calling something else. I might not know, the meaning of those. Yes, of course not. But from the perspective of the structure of the code, there's a lot of structure there. And interestingly enough, your development environment knows about it. It just doesn't make it available for you because of some unfortunate historical events, I guess. But that's basically what we want to turn around. But I'm suggesting, what if I show you a couple of examples?
Sure.
So let me share the screen. Okay, so this is Glamorous Toolkit, and I took here a couple of examples that that we've been playing with recently. I think you mentioned, well, you just mentioned the database and how you can start to reason about the database. And there's one thing we played with, which is Ruby on Rails here. So if I look at this one, I can say, here I built a model. And so in this model, I have classes and I have methods and I have, I don't know, attributes and how methods access attributes and so on. But the one thing here is in Ruby on Rails, you can have these classes which are called application records. And if I look at this class here in this system, I can see that these are hierarchies, right? So I'm looking at the class. I can of course just look at the source code. In this case, it's just a superclass of components, and I can see it here. This one in blue. But then I can see, like, okay, these are all the hierarchies there. So if I now click on this box here, I go to another class, and this call is called addition. I can see the source code is here.
Can you
What is
pause here for a second?
sure?
Because like I have a couple of questions around this, because like I could see also a couple of examples like this on the website, and the questions that appear on my mind are like, first of all, is that because that is an application, and I assume that's macOS, right? And
Oh yeah,
so this is an application.
desktop.
All right, so this is a desktop application, and is it also distributed for Linux, for Windows, maybe
Yes.
on web platform?
No, just Linux
How does this
at
work?
this moment in time. It's a desktop application on Mac,
Mhm.
Linux, and Windows.
All right. So in order for developers to use it for a code base, they need like a separate location, and that's where the custom tools reside. And the tools that you're showing, like, I always wonder what part of it is custom made for the code base you're showing, and which of it is like provided by the framework, maybe. Because you know, I'm trying to estimate the effort that goes into building such tools, right?
Sure.
In
So
order to make a
here,
decision whether that makes sense for me, for instance,
right. So
personally.
Glamorous Toolkit is you're gonna have your generic things. We can go into those, but basically you have a language workbench at the bottom, very generic, and then you have a couple of layers on top. You have a graphical stack around it, the visualizations part of it. Um, but on the analysis side, we also have a few applications that are mostly taken as examples. So just to show people, here's an example of
Mm-hmm.
how it would be like here, for example, we have Ruby on Rails. So this requires Rails, and then on top of Rails, you'll have Ruby, very much like how you would have JavaScript and then React.
Yeah.
So, and the example here is, right? So tools, if I have a Ruby on Rails application and I'm just going to look at the Ruby code, I'm going to miss most of the picture. Because while it is indeed the underlying language is Ruby, there's lots of magic in the Rails framework that my tools have to take into account. And if they don't, I'm going to just miss a lot of things. And so here, this is an example of how would you do this? How would you map that onto a system like this? But with our system, you can go from not knowing the language, like we are a consulting company, and one of the ways in which we earn money is by going and working with systems that are in some sort of a crisis around the legacy. And there we sometimes have to reverse engineer not just the system, we have to reverse engineer the language sometimes. Like people don't know what that language is, and maybe it's not just one language, maybe it's more. And so we have all the tools that we need to build the entire stack, right? So along this way, right, there's a continuum, and as far as, for example, for C#, there's already going to be a parser, so you don't have to build that one, right? But then on top of it, you might want to build the next level of semantics, and then the next one, which are specific to a certain framework, and then the next one, which is specific to a certain domain, and so on. So these are basically examples, and many of them actually come with the framework. So as just as an extended library of examples, and others are just loadable also on demand. So this one here, the one for the Ruby on Rails, is actually an example that comes with Glamorous Toolkit out of the box. Okay, so
And this is a diagram of entities.
Oh, this is a simple one. Yeah, no, this is a diagram of, given a class, show me all its subclasses and superclasses.
Okay.
So
and
there's nothing.
It's like it's one of the inbuilt
Yeah, so
things,
this is.
or is it hand coded for the specific?
So we can take a look.
Framework.
I just alt clicked on this, and we're looking here on the right hand side. This is the code that shows this. That's it. There's the entire code. So we can, for example, make it this one. We can make it red, and If I save this one, then that thing is going to be right there.
So is this like a custom notation for Glamorous Toolkit, or
This
is
is
it
a language
some?
here.
Mhm.
This is Faro.
Oh, okay. Okay.
So the underlying, everything is programmed
Mhm.
in Faro. Faro is both the scripting language, it's the implementation language. There's no difference between them.
Okay.
And of course, then we're going to have different libraries for constructing from different, um, sometimes visual representations, a library maybe for parsing, another library for querying, another so on.
Mhm.
So, and those are all combinable, right? So there's nothing, but that's it. This is the whole, that's the entire source code over here. There's nothing else to show this one. So if I read this one, it basically says there are some nodes here with all the classes in the all the subclasses, all the superclasses, and then afterwards I'm going to create edges starting from the superclasses to the subclasses, and then lay them out in tree.
Mhm.
And this is
So
what this one here.
say if I wanted to, like, today take one of the C# .NET framework kind of legacy code bases I work on, and I wanted to apply tools in the Glamorous toolkit to it. Does it mean
Sure.
I would need to start using Faro, right? In order to, start
Yeah.
building
If
these
you
tools, even modifying those tools.
well, that's the thing, right? So Glamorous Toolkit is not a thing that you click on, because
Hmm.
like you can click as much as it's interesting, but that you
Yeah,
soon run out of interesting clicks,
yeah.
because right, the tool has to be specific to the question, which, and
Hmm.
given that I cannot predict what the question is going to be, the most interesting way
Hmm.
to support the to support that to accommodate that unpredictability is to give you a programmable tool,
Hmm. Yeah.
basically.
So
So
yeah,
yeah,
so that's
programmable is
reasonable,
fine.
and I expected it that much. It's just that, my first intuition when, I'm a C# programmer. I work mostly on C# code. So if I want to build a custom tool to power my day-to-day work, I'm probably gonna start looking at C# because that's what I'm comfortable in. Like that's that seems to me like a potential barrier for entry into moldable
Oh,
development, because
oh,
you
sure,
gotta learn a new language to be able to utilize those tools.
sure. Yeah, so we hear this one a lot, right? And the answer we give is the following. Um, there are people that understand when a new opportunity appears, and they want to jump on it before the other ones do. And then there are those that need to be convinced because the other ones have jumped on it. So right now we're looking for the people that understand that the upside of building custom tools is so large that no matter the cost, the apparent cost today, um, the benefit is will vastly it will be vastly larger than any cost
Hmm.
that people will learn. So I'm simply suggesting that, given the developers today don't know how to answer the question, how do you read code? And given that this is what occupies the single largest, this is the single largest expense people have. And so that should be the largest alarm bell, right? Not whether or not it's the most comfortable thing. This is the environment where we have went the furthest. We started from this idea, and then we built a whole environment that supports it in many, many different ways, not just source code analysis. So what happens when you're going to do log analysis? What happens when you're going to do JavaScript analysis? Are you going to switch to JavaScript then? It's possible, it's feasible,
Hmm.
of course, but there are many more ways to slice and dice a system than people are comfortable accepting today, right? At the same time, people are just going to take another SaaS tool to give them some sliver of some input, and then jump to another one and another one and another one. So that's another approach that we think doesn't really work. The other thing to keep in mind here is our thesis is that figuring the system out is going to be the largest competitive advantage for the next decade. So I don't want to convince people to use this one. Some will, if they find it compelling enough, some won't. But obviously, at the end of the day, there will be many more technologies that will enable these ideas. Our main goal for now is to define what this space should be. And the other one is to make sure that people, when they copy what we do, that they copy it properly and not just half of it, which is the most likely event. So I wouldn't worry so much about that. I mean, at this point, but let's see, first of all, what is possible, and then we're going to say what are the practical things.
All right.
If it's worthwhile at all. So here, for example, I wanted to show you this one just as an example of what happens when I have, this is source code here. Now, this is an application record or an active record. It's when you create a class like this, it's going to be mapped automatically on a table on a database. And if you're going to define fields in the database, they are going to appear as if magically or automagically as fields in this class. Which means that if you want to understand this class, you cannot just look at this source code. You also have to go and look at the table side of things. So you have to look at this too. So this alone, right? This is just a simple example of saying, when people say, is this, is Ruby on Rails Ruby? Well, yeah, plus SQL right here. Because if you're not looking at this, you're missing the point. And so that's that's a problem. Now, of course, if I do something like this, then I can also do something like this. So here's the list of all attributes. So here, those with those are defined locally, like in the Ruby code. But the other ones, they come from the database.
So the parallel to like my world would be entity framework database first approach.
Yes. Right. And but here, right, remember, like Ruby is a dynamically typed language, right? It's like with JavaScript, where, well, it's not as bad, but it's similar, right, in the sense that you don't know the types necessarily statically. Except, however, if you take into account the specifics of the framework. For example, here, there is a document field in the table associated with this edition class, which actually points to another, has a foreign key to another table, which of course will be mapping onto another class, which means that if I look at this one, and if I take into account the specifics of the framework, all of a sudden I can be much more specific than if I would have been just by looking at the Ruby class, right? And so if I do something like this, I can build maybe something like this. I can say, okay, look, addition actually has this dependency statically without even looking at many other patterns there, just very simple kinds of analysis. And then, of course, if I can do something like this, I can also do like a transitive closure, for example, of my domain. Right, and I can see this one points to this one, and if I click on role appointment, for example, now I'm looking at role appointment. So somewhere here, there's going to be a link from role appointment to role and to person. And then this is basically how you can, like here, there was you see here, role ID and person ID, which are foreign keys to these other two things. So again, and then from here, right, we've built now a little browser, which is kind of custom, which is not Ruby specific, but it takes the Rails semantics into account. So these are the types of things that are possible once you start to build tools at the level of abstraction that you're actually interested in. Other kinds of things are, this one here. So these are, like when, for example, this is a get.
So this finds all the controllers in the project.
Exactly, right?
And
So this will gonna find all the controllers, and I'm gonna now have a browser here, which gives me the thing, but not only
mhm,
that, but it tells me, oh, look at this one. This one actually has get, post, and two gets
mhm.
actually mapped onto it. And then I can see where is the logic defined. And now I have a browser like this. So
Now, how does this tool actually work? Like, how does it find the does it use some framework concept to identify the?
sure, of course,
Okay.
because you
What?
must know that this one,
Hmm.
that this is the keyword, that this is like this, because
Yes.
this is framework specific.
Okay.
But that's
Now,
the advantage that you have.
now, my next question would be like, what if the framework introduces a new way of
Sure,
denoting this functionality? Then
sure.
then your tools would need to change, right?
It, obviously, just like what
Hmm.
happens when you're introducing some new variation in your business domain, your tests have to change.
Hmm.
Yes, they do. Sometimes it's harder to identify those, right? This is why the tool itself is not enough. That's why moldable development is a practice. So when you have a new affordability with the tool, the interesting value is extracting when you're actually changing processes, when you're changing the way you're thinking, because now you have simply you have new options available. And when you
Hmm.
have new options available, you want to change the way you're working. And so when you start to have, when you're integrating architectural decisions all the time, when you're saying, oh, I really would like to see this kind of thing, you're going through it and you notice some strange new thing, new pattern that says, oh, why, what is this? How many other are there in the system? And now we're going to go and see, oh, is this possibly a variation of that? And but if you have a place where you get those kinds of conversation going, then this is how you're anchoring the what you could possibly miss. So much of the work, when people talk about architecture, like there's no real place today where people negotiate architecture. There are places where people decide this is what the architecture is going to be, but not where they negotiate what's the difference between what people think and what people see. Um, and tools like this and would enable you to actually put in place a conversation that is much cheaper. So we can have conversation that actually lasts for minutes, and at the end of those, you actually make a decision as a team, just because you get to see
Hmm.
very concrete inputs. It completely changes how people think about their system and how you can. So, for example, migrations going from some state to another state typically
Hmm.
boils down to let's find all the old ways of doing things and making sure I don't have them anymore. And that's what a migration is. It's really like when you have these kinds of tools, lots of things that appear
Hmm.
complicated and mythical and magical and mystical, um, they just become normal.
Yeah.
So
One
anyway,
example that comes to my mind from my recent work is like, so you often see state machines in code, and we
sure,
we
exactly.
also we also
Yes.
do have in the plugin that my team is developing, we do have a state machine for some scheduled jobs, and we are really in active development right now, so it changes sometimes, and each time it changes, we do have diagrams for it, and each time it changes, somebody goes into Lucid Chart and adjusts the diagram, and so that it reflects
Nice.
the new state of the system. So that's kind of a use case for something like this. Like if you could tie it into the code, it would be much easier to have a meeting next week with the team, asking them like, do you think this new state I'm introducing here makes sense?
Oh yeah.
Yeah.
So the way we do this, right? When you want to facilitate architectural conversations like this, you want to take this and then deploy it in your continuous integration and continuous delivery pipeline,
Mm-hmm.
and then have the conversations like that. So everything you see here, running in a UI
Mm-hmm.
can also run headlessly,
Okay.
and
Well,
you can
that was
integrate
my
those.
next question. Yeah. Not nice.
Right. And everything that you see here, right? Whenever I like something, I'm prototyping here. You can think of it like a development environment for my analysis, kind of. Um, But as soon as I like something, I'm going to publish it on, for example, GitHub or some a repository like that, and I'm just going to load it next time, very much like you would build a Docker image.
Yeah, and it also kind of reminds me about it reminds me of sharing SQL snippets that you use when you're troubleshooting problems and bugs. Yeah.
Right. Yeah, so it can be like that, except that here we can sometimes, like most of the time, you're also going to build models that go closer to your domain. So you can organize those snippets much better. So when I will introduce the notion of a, like your state machine, a state is going to be a first-class entity that I want to be able to query by. Just like how the route was there before, right? And I have a route in my system somewhere, or that's going to be a first-class entity that is enriched. So next to my class and methods and so, I will also have a route that will point to one of these methods. It's just a sea of entities that describe things of interest. And so as soon as you, and that's why, and then you're going to put, the route will know, oh, give me the, I don't know, the places where it's, get and set and post, where the controller is, where the definition is, and so, and then this is how you manage that kind of complexity. So it's not just a list of snippets, an unordered one. But maybe something that is maybe closer to your environment. So this is JavaScript here. So and here I'm just looking at, this is not a model of JavaScript. I'm just browsing this folder here.
Yeah.
So I'm looking at what you're seeing here on the screen on the left hand side. You basically see a kind of a notebook,
like
if
a notebook,
you want.
yeah, like a Jupyter or something.
But this notebook is actually part of a knowledge base. So it's already a knowledge management that you can actually use to, you can commit it into your Git as a documentation for your system. So it can go together with the system that you're documenting, and you can have links between those. So for example, here I can see there are two places that are connecting to this page, and I can go there if I want to.
Okay, and the snippets on the left-hand side, they are also in Pharo, right?
These ones, yes, but we can also have snippets already in Python or JavaScript directly here, and then we can even exchange objects. So you can build an object here. If I have something that manipulate, if you have your state machine, and maybe that one is implemented in JavaScript or in .NET, and you want to connect to it, then it would, it's like nice to say, oh, actually, could you give me the data, and I'm not going to implement that logic again, and it would. You can interact with that one, and then you get some objects, and then you can play with the analysis that are more suitable for this one here. And then on the right-hand side here, this is an object inspector. It's just a normal object inspector, but which is normally, what you normally see here is just variables and values. But because there's no single perspective that is interesting in software, everything is moldable. Everything can be looked at from multiple perspectives. So in starting with the inspector, every inspector basically can give you all of these different views onto it. So here, for example, I have package.json. I just like giving this demo because it's like the simplest kind of demo that shows you it's not. So this is a JSON, right? This is not really code. But here I have a list of dependencies, right? And I can see, oh, look, this one goes to React Native, this one to Redux, and this one to Lambda, and this one to Patch. But there are many that goes to React Native here, right? So a simple question, right? And it's a question. So how many dependencies do I have that do not go to React Native? So how do we find this info? How do we find this answer? Because it's a simple answer, right?
So
the whole data
you
is
would
even
start
here.
You would start reading and counting, right? You probably want to
like,
automate this somehow.
And it's annoying, right? Isn't it annoying?
It is, yeah.
It is annoying, right? But this is now JSON. This is not just plain text. This is JSON, which means that I can, for example, parse it. So if I now take a thing from here, right? So this is now a playground, a notebook within the context of this object. So self here means this file reference. So if I now save contents, and I inspect this one, it's going to give me a string, the string with the JSON, right? And if I have the string and I say, well, I already have a parser and it's called stone JSON here. And I say from string, and I say self contents, and I get a dictionary back.
Nice.
So now I have this one and this one. So because I have that, now I can say, okay, actually, can you give me those at dependencies? Because I noticed that this is the key. So if I look at this one, I can see, look, it is a dictionary of 40 items here. And actually, I don't want it as a dictionary. I just want it as an array. So, so when I do this, I'm going to get an array of things. And I'm going to say here, select each of these for which the key, I think, right? The key includes substring React.
Would
native.
the notation be similar if that was XML? You would just switch out the parser and
just the
rest
parser,
could
and
stay
then
the same.
Yeah, okay. And these are things. So when I get an XML, I will get XML elements, and if I want to know, for example, what's possible to do with this array, right? So for example, this select, I can go to the meta, which gives me a view on the implementation of the object of the implementation of the class of the object that I'm inspecting right now. And I can just browse the source code from there and then figure out what do I want to get from there, right? So, so here, if I do something like this, then it gives me all those that are React Native. And if I'm going to reject those, I'm going to get those that I'm interested in. These are 18. And that's it. So
when you want to save it and share it, like how does it look like? You copy it to a notebook, or how does it work?
I will promote it as a piece of code. You can put it as a notebook. This is a possibility, and you have your notebook as part of your knowledge management that you then commit next to your code as a project. But it also interesting would be, for example, now what if every time I look at the package.json, I will see all the dependencies, for example? Why not?
So this is
so
like
what if I have a new view? Exactly, a new view here. Yeah. So how would I do this? Well, the way we do this is by all of these views are methods. You can think of them like a toString kind of methods. And the way you put, you have a toString, you put it always in the class of the object that you want to print. Yeah. But here we have not, is because it's 21st century, so we can print views. We don't have to limit ourselves to strings. So it's like a view. And then because we have multiple of them, we have to distinguish them. So here I'm going to just create a package JSON dependencies. And here I get here I'm defining a method, and let's put it here, it's easier. So this is a new method, and this is an argument. You can think of this argument as like a stream, but it's a visual stream, basically. And this is an annotation. So like in Java, you have an at something. Yeah. So I'm annotating this method that this represents a view so that it's discoverable by the tool. And then I'm going to say here, I want a view. And in this view, I want to, I don't know, maybe first I'm just going to start with the list. And I'm going to say package.json dependencies. And there I'm going to say I want to put the items there. And for the items, I'm just going to take exactly what I have here. And I'm putting it there. And if I save this, right, I now save this one, a new view appeared here.
Okay, so now that you click save, where did it save? Like
in the image,
a file in the drive, or?
No, it's at the moment is in the image. I can take it and commit it into a Git repository on disk, and then into a Git repository remotely.
What's the format that GT saves? all those views and
So there's
associations with files and
as this is a Smalltalk system, and Smalltalk system is made out of a virtual machine and an image, which is binary. It's just a memory representation, basically.
Okay.
It also has source code, but the source code is externalized. It very much like you're exporting it basically out of the image. So here we're in the image. Nothing touches the disk except for a trace of changes and stuff like this. But it's not yet exported. But then if I want to, I can go into into Git, and then from here I can just directly commit, for example, to GitHub. These are all the projects that we have loaded from GitHub. These are the projects that make GT itself.
Can I put it right next to my code base and
Yes, you
and
put it
open it
wherever you
from there
want.
as well? Can I because I'm thinking about somebody wrote a view from the code base I'm working on. I'm let's say a new developer on the team. I download the code, I clone the repository, I run build, and now I want to get down to working with Glamorous Toolkit. Like, what do I have to do? Do I have to I have to download the application first of all, right? And then can I just open the exported file from the repository and then work on it and
You
then
will
save
have a
it?
little. Okay. Here's an example of that. So this is an example of that we've done for a specific system. This is a Python system, and when you execute this piece of code, it will load the code specific to this system into Glamorous Toolkit, and those views will then be available.
Oh, okay. So it's okay. Yeah.
But you can also automate this one. So, for example, you don't have to take the default Glamorous Toolkit. You can just make it part of your normal build to say, here's an image, just download it anytime you want.
And when you import this repository, like, do the views also get
yes
imported?
So here I've already done this one for you, and here, for example, I have a bunch of things that I could show here. So you can look at, this is now a model, and in this case we didn't model the whole thing. We just wanted to look at the feature toggles, how feature toggles are being defined, and here they had a bunch of them. So in fact, these are all the places in the system that are using the feature toggles. So all the red parts, right? So quite a lot of usages. And in fact, here, there were a number of them, a number of these ones actually are represented in an older framework that they wanted to migrate, which is it's actually called a legacy thing. So these ones are one of those feature toggles that they wanted to migrate. So if I look at this one, it shows me here, it says it's even called a legacy waffle flag. And this is how the feature toggle was defined. So now this is one of those kinds of cases where you say, I have a goal, I want to migrate from A to B. I don't want to have the legacy anymore. I just want the other ones. So now I can transform this little query over here into something that I can put it into continuous integration. And as long as this one is not 0, the test will fail, or at least will give me the result, because I still have to-dos, right? So
yeah, and that's actually
then,
effort that will, like, when you have a huge migration project, it really pays off to create something like this at the start, and then make it available to the developers and as a guideline, essentially. So they don't have to repeat the steps manually.
Exactly. This is one. But so first of all, right, whenever you're going to do a migration, you want to know, how far are you, right? And you will do this check is the most expensive thing. Not figuring out what do you want to do afterwards. It's finding out, how long are you?
Yeah.
And how long do you still have? Because that's where it gets difficult. In fact, this is no, it's not difficult, but that's what is the most tedious thing. You see, with multiple development, what we do away with is the boring part of decision making, which is just gathering information. Once you have information, well, then it becomes interesting. It's also about this one. So for example, here, let's say you want to know which ones are more interesting first, because it's not just whether or not they're legacy or not, but let's say that you want to split, these are the modules and you want to split them, put them in different services, for example. Well, you will take a look when you're doing a splitting, you're going to take a look at dependencies. But these dependencies here are not dependencies based on code. These are dependencies that are induced by feature toggles. So these are dependencies where I define a feature toggle in one module, and I'm going to rely on this feature toggle in another module. So all of a sudden, right, even if I don't have direct calls, there is a hidden contract between the two teams, and I cannot just split this one apart. So, and this is an example, one of those examples. There are so many of these kinds of things in a system.
Yeah, the sneaky kind of dependency. Yeah,
yeah.
the ones that
and
are not visible to most automated tools.
no, you cannot build an out-of-the-box automated tool because nobody knows the semantics of these things here.
Yes.
That's the thing. And so this is actually an open source system. When we had the opportunity to go to participate in one of their hackathons, and it's a very well-funded system. And it's not like they miss or they lack ability or the engineering effort. And still, there were issues that we could find within a matter of a couple of days, starting from not knowing anything, just with the basic Python parser. And then within a couple of days, starting to be able to say about this specific topic, more information than maybe the team already knows. And this is the kind of thing, and again, like this is just a simple problem. We're not talking about the very large problem. How do you do the migration? The larger the problem, simply the more the economics make sense. But for us, the most interesting thing is not to solve the large problems, is to solve the smallest possible problems. Because if we solve the smallest possible problems using the same kinds of tools and the same kinds of techniques, it means that you can learn them once and you reuse that ability over and over and over again in a very large amount of situations. And that's basically the most interesting part of multiple development. And that's the part that we have actually difficulties explaining. When people come to GT, they will see the thing that they are prepared to see. But there is much more here, because we are simply saying the way people decompose problems today is wrong. It's very, very limiting, and it's unnecessarily limiting.
Yeah, because it is rooted in the practices that like everybody applies today. So it's really hard to switch your thinking to a different mode.
Exactly. And we understand that one, and that's why we are saying this is not just a tool. Because if you're just looking at the tool and you don't see these other consequences of it, you're not in a position to understand the economics that this whole new approach proposes, right? So here, for example, I mean, this is a picture, right? I just drew it, but it's not just a picture, because I can click on it and I can see where it's being used, exactly like I've done before, but now with a super domain specific thing that nobody else would have. You can now imagine the same thing doing with your state machine, with all sorts of things, like having the connection between your JavaScript source code and the server side part, through the API calls. That is a specific library on the JavaScript, and you have another library in which you're defining the API calls, the routes on the server side, and you have a connection between them, and so on. So, for example, when is that one interesting? Is when you want to split not only the server side but also the client side, and so on.
So I remember once when I was doing discovery of an old legacy service that was developed like 15 years prior to me being at the company, and nobody was sure even of the functional requirements of the project anymore. I started decomposing it into modules, and basically what I did, I would create diagrams of modules, and I think I was using Draw.io back then, but I would link each of the elements to the part of the code base that it was referencing. And it really this, what I'm seeing right now, reminds me of that kind of approach, but it's like it's obviously more dynamic and easier to implement, I guess, in the end than creating a diagram and copying all the links and making sure the elements are clickable and
Yeah. So as I said, like you take away the boring part of the decision making. And there's one thing people say, okay, so people are saying, so is this going to make me will I be spending less time making decisions? And the thing is probably the answer is no. It's just that your decisions are going to be way better. So you're going to spend less time making the same decision. And that's where the difference is. You see, most people today spend time deliberating until the time expires, not until they have confidence in the decision. And what we're saying is that, well, the limiting factor should be whether or not you reached your, the confidence level that you were looking for, not whether or not you ran out of time and you have to guess something. So
I think it's also like I think it's also worth highlighting the temperament of programmers, because programmers are mostly people who like tinkering, they like automating things. They quickly get bored when they get assigned work that is repetitive and, as you're saying, just outright boring, right? And I really like the approach of automating whatever you can, or rather whatever makes sense, because like sometimes it's better to do something by hand in 5 minutes than to write a script for it and let it take an hour of your day. So it's obviously not as simple of a rule, but in general, whenever I can automate things, it's more interesting to me. It's more engaging for people, and I think even discovery of legacy code bases can be made more interesting for people if approached this way. And that, I think that's actually a huge problem for companies that are trying to employ developers to work on projects that are not necessarily in active development but need to be maintained, need to be migrated, um, need to be figured out first before that happens, obviously. And programmers, they often don't want to engage in such projects. I think precisely because there's so much of manual work like this involved, like reading the code and trying to figure it out. If you could do that while actually writing code, that would, I think, speak to people. Like,
well, so this is why what you're seeing here is this is not a tool for just analysis. So you have a knowledge management system that you can use for documenting things. So today there aren't really proper tools for doing anything like that. So here, for example, is one of those examples where you said, I now change from red to blue. This one, right? And I'm gonna now open the Git integration, and here is the repository, and this is GT4EDX. It's in GitHub. I can also take a look here and see, oh, look, it also has a knowledge base of 6 pages in there. And this is basically the change that I made. So from red to blue, and I can just simply commit it from here. And that was it. And next time I'm going to build the same thing, I will have it blue, not red. And that's the flow. That's it. So it can be completely integrated for that purpose, basically. But the other, so you said something interesting, like it's about automation, which is I agree with, because that's exactly what we're doing here, except that people today only mostly automate the construction side of things. They do not automate enough the reading part.
Yeah.
And when I say enough, I'm saying that if people don't build a dozen queries per day over their system, and maybe a couple of pictures per day over their system, they're doing something. They're not reaching the potential
Yeah, because
of what it should be
it's
possible.
the artifacts of what you're describing are less visible because they're essentially in your head. Like you can see it
Yeah,
when you do construction automation. Like you said, you can see the actual outcome. When you do discovery, everything that you discover first ends up in your head, and it's sometimes hard to realize how much of it is there and how much mental space it occupies, stuff like this.
yeah, and that's why we're saying that the first thing we want to do is get people talk about how they read code, or how they should not read code. And like I've just went with you through a couple of things, and we haven't really read code as a means to to reason about a piece of system. And that's the kind of thing where you started from this, the compaction of communication, and that's just the main interest. The most interesting side effect of multiple development is that it leads to a compressed communication, which opens up all sorts of interesting opportunities afterwards. So it works for the individual, and it gets even more interesting when you're considering groups of people that want to work in concert and make decisions together.
Because then the communication has to be compressed somehow, like between the
Well,
teams, between
today,
the
right?
managers and the technical people.
Right, but today it works somehow, right? What if you can improve that one with an order of magnitude?
Yeah.
And that's what we're saying. And this is the change is so large, and the opportunities that come with it are so large that it can be converted into business value rather quickly. So here we just looked at some technical things. How do I query my source code? Well, we can do the same with discovering APIs that they have no documentation. We use it to reverse engineer data. For example, data coming from social platforms like Facebook or Twitter or so. Um, so they give you a bunch of data and nobody knows what's in there, and we could build a model of what's inside of there. We can browse that one, we can visualize those, we can understand connections, we can understand consequences of actions and what they did with those things, just by without having zero documentation about uh, that uh, that data. We use this one to document business domains, not only like reasoning about the domain objects, not about the source code, but about like what they mean and visualize the business domain. So every time, like very often people, for example, do domain-driven design, they're gonna draw it on the whiteboard, and and they and they're going to be there not only UML kinds of drawings, but other types of drawings, maybe of links and flows and that or entities that are not describable in a specific kind of a language, a formal language, but just a notation that makes sense for the person that has drawn it, and maybe for the person that has looked at the picture. So every time somebody draws something like this about the system, anything, it can be technical, it can be domain, it can be, doesn't matter what it is, what picture people drew on a napkin, on a whiteboard, that picture is meaningful when I don't have a system. It's meaningful to use a whiteboard for that. But as soon as I have a system, it should be the responsibility of the system to provide me with a picture. That's the principle. How you achieve it doesn't really matter. As long, of course, now, in order for this one to work, the cost of creating these tools must be really low. And so this is why you need an environment which makes this one very, very small, or the smallest possible cost you can have. And the other thing that we're showing here is that you can have one environment for a gazillion of different kinds of analysis. And instead of optimizing, oh, I'm very good at doing da, 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 we're using that tool, and it will only do this set of types of analysis, but you cannot do the rest of them. That's where we find that the model doesn't really work. You want something that is, this will only work if it's applicable in a wide range of situations that are unpredictable. And so that's where basically the research, most of the research effort has been spent over the last decade to find what was an interesting set of operators that I can combine maybe in many different ways and still have a cohesive platform.
And it does make sense to me now that it is not language specific, because
yeah,
like you said, it's about not just one component, it's about the entire system where you have multiple different technologies. And like I can, now that I understand kind of the underlying principle behind it, like I can imagine creating something like this in JavaScript or C#, but it would still need to apply to all kinds of technologies, all kinds of different frameworks, and would have to provide all kinds of connectors, parsers for things, and would essentially be similar in functionality to the current Glamorous toolkit.
Yes, it's just gonna be, would be a different way to express the main logic. But this argument, right, about that I would like it in the language in which I'm writing, it can be relevant, but that's not where the cost is. Right?
Yeah.
Today, right? When I talk with people and I say, do you agree that you spend all this amount of time reading code? And they say yes. We're talking about, 50% of the budget. Let's say you have, I don't know, what was it? I think last GitHub report that I saw was pointed to something like 50 million or something like that. Say each of them, does cost 10,000 per year. So we're talking about, $500 billion every year. So $250 billion every single year is being spent on a single activity nobody talks about. And it's the most manual possible thing. And we own the budget, right? We don't have to ask anybody's permission because it's us, right? We're spending it. That's the opportunity. That's the interesting thing. And so that's where the real cost goes. Everything else is, yeah, of course. I mean, this is the first thing of the first kind of environment of this kind. And the main purpose of it is to show, well, there is something to talk about here. It's not a end of the conversation. And we also think it can be the difference between, people disliking working on legacy system or people smiling when they work with legacy system.
Yeah, I definitely agree. Yeah.
So, but yeah, thank you, thank you for the interest, and I'd be very interested to find ways to, like, what would be an interesting message, or how would you describe it now that you've taken a bit more time, which is not what typically people do. So thank you for that. Now that you've spent some time looking at it, how would you then describe it to somebody that is willing to just get something done with in a few minutes or seconds?
Yeah.
So,
yeah,
I'm gonna think about we should look at it today.
Yeah, I'm gonna think about it, and I'm also gonna have some conversations with other people in the field, because like the reason I'm taking interest in it is like precisely because I don't think we talk about this enough. Because like if you're spending on one activity, if you're spending half of your time at work on a kind of activity, it's worth exploring in a lot of different ways and just looking for ways to improve it, because it's crazy to think, and like, it's obviously, it's hard to perform research when it comes to software development. It's hard to measure those things, but this statistic, like, I haven't found a person yet who disagrees with this factoid that, that reading the code takes half of your time. Like, everybody's like, well, yeah, so
Sure.
And yeah, it's worth to take steps in that direction.
Great. Well, thank you very much.
All right. Thank you so much.
I hope to continue the conversation and see you in our community. Thank you.
Sure.
Bye.
Thank you so much. Have a nice day. Bye-bye.